Hello guys, for those of you who haven't seen one of my videos, my name is Jonah and I'm going to be going over my Project 3 for CSC 180, Human Intelligence. So here's my project. I'm going to be going over two things. The two things that I did was training and testing a CNN network on a dataset that was provided to us with transfer learning and without transfer learning on GPU. So the things that you just saw were method declarations, and then here we have myself reading in the dataset, splitting it into X train and test and Y train and test, testing to see whether or not I'm on a GPU. Was never able to tell whether I was on one, just keep getting no output. Just testing X train here, and then also just printing out the image in a location of this array just to see whether or not I actually have images in here. You can tell that I do. It's a 32 by 32 image of what seems to be like a truck. Reshaping Y, and then one-hot encoding it into the same array that it was originally in, converting it to a float 32 for normalization, but then normalizing those data in between 0 and 1 so that way they can be used with my model. Printing out all of the shapes of everything to make sure that they're appropriate shape, and then just looking at the training samples and test samples again. This is my model right here. It's a sequential model. I have the input shape established here with 32 by 32, I believe. I've got a couple of convolutional layers, max pooling, and then a fully connected layer below. I'm using softmax as that last layer, and then these are some of my dense layers. This is a summary. And then I'll get straight into the results basically. Yeah, so you can see the accuracy right here, beginning at 24, 30, 33, 34, kind of building up to 46. It didn't actually hit an early stop either. It went all at 10 epochs, so I'm kind of wondering what would have happened if I kept it going. But anyway, for the sake of this video, accuracy ended up being 0.39, so 39% accuracy, not too bad. So now we'll move on to pretty much the same thing using the VGG model and transfer learning. So I load back in the data. This is the data set that we're using. We're not using the data set from VGG, which is something like 1.2 million pictures or something like that. At least I don't think we are. And then I'm going to create a NumPy array of a certain size, and then I'm going to read in xtrain and xtest into that array after I resize it into a 64 by 64, and that's exactly what I do right here, is I'm testing the image in xtrain position 0 to see whether or not this is a 64 by 64 image, and I'm also testing to see whether or not I got a 64 by 64 image here as well. So this is train and this is test, and I do. So in that case, I'm ready to move on to Y, and that's essentially what I do. I don't run this piece of code. This is reshaping, so that was basically redundant. I'm going to one-hot encode Y train and Y test, and then I'm basically going to start building out the model. So I bring in the VGG model, I create a sequential model, and then I iterate through the VGG model layers, and then for each layer I add it to my sequential model. I print the model summary, and then I'm going to iterate through all the layers in model now, and I'm going to freeze them so that way that we enable transfer learning. I'm going to flatten and then add some dense layers and then end it with a softmax. Here's the model summary. It says model VGG 16. That's what we're dealing with here, and these are all of our layers. I'm going to establish an optimizer, compile it with a couple of different metrics, and then yeah, I'm going to fit it with early stopping and model checkpoint. So these are my test results right here. Unfortunately, they're not as amazing as I would like to have seen. Would have definitely liked to get a 92% accuracy as the model is supposed to or intended to be achieved. But I start here at 50 and I build up to 55, so really not much progress in these 8 epochs. I actually even hit early stopping because I'm not making any progress in my predictions. And then the results are right here. So this came out with about 0.49, so 50% accuracy in predicting what. So a little bit better than the non-transfer learning, but not as good as I hoped. So I am really excited to see what you guys did and what you guys did differently. Alright, thank you so much for watching. I appreciate you guys taking your time.